Alright, I want to talk real quick about how to solve an inequality and then represent it on a table. Now, what we're going to be using in class is we're going to be checking these solutions on a calculator, but sometimes you're going to either need to set up your own table like this, or you may need to recognize it when you see it. So, first thing we got to do is we got to solve the inequality. We solve it just like it was an equation. So I subtract 1 from both sides. That leaves me with 2x on the left, 6 on the right. I divide both sides by 2. There we go. I get x and 3. Remember, because it's an inequality, I didn't divide by a positive or negative, so my inequality sign stays the same, right? Making sure we're not putting an equal. Now, once I have my solution, now I'm ready for the table. So first thing I want to say is I want to start by looking at my solution here, where x is greater than 3. That's what I want to start on my table. So I'm going to go ahead and put that right in the middle, right here. That way I can see some numbers above it, and I can see some numbers below it. Once I have that, I'm just going to fill out my x's accordingly. So we go in order. 1, 2, 3, 4, 5, 6. Right? We just want some different examples up there so we can see what's going on. Now, I need my y section. In inequalities, we only have one y column, and that's going to be our solutions to the expression on the left, this here, this 2x plus 1, when I plug in different x values. So I'm going to start and show you how to get our first y1 value, where my x is 1. So I'm going to rewrite my inequality, or my expression, excuse me, where x is 1. So I have 2 times 1, which is 2, plus 1 is 3. And that's what goes in y1. Now I do the same thing for the next one. 2 times 2 plus 1. 2 times 2 is 4, plus 1 is 5. And there is my second y value. I'll continue that process for the rest of my table. 3 times 2 is 6, plus 1 is 7. 4 times 2 is 8, plus 1 is 9. 5 times 2 is 10, plus 1 is 11. And 6 times 2 is 12, plus 1 is 13. So now I have my y values figured out. Now, since this is an inequality, there are more than one solution to this inequality, right? I want all my solutions where x is greater than 3. Now, if this is greater than 3, it doesn't include 3. So the first one I'm going to have is I'm going to draw a line right above the first solution that is included, which is 4. Because over here it says that x has to be greater than 3, not including. Now, what I'm going to do is all numbers then that are greater than 3 are going to be included in my solution. So now what our table does here is it shows us that this is true. So look right here. If I look at, say, this line where my x is 2. If I look at my solution, I want to check, is 5 greater than 7? No, it's not. That's why these values on the top are not included in my solution set. Also, if we look at here, 7 is not greater than 7. It's equal to, but it's not greater than. If I look at my solutions that are included, 9 greater than 7, check, that works. 11 greater than 7, check, that works. 13 greater than 7, check, that works. So what we're doing with our table is we're showing that when I have these x values and everything beyond that, my y values on my right side are all going to make my original inequality in my original statement true. So that's what we're looking for. Now, if this was, say, instead of a greater sign, if it was greater than or equal to, my situation would change a little bit. So say I had greater than or equal to 3. Now, the only difference is I include that 3 in my solution because 7 is greater than or equal to 7. 9 is greater than or equal to. 11 is greater than or equal to. 13 is greater than or equal to. So on, so on. So there's a slight difference between just my greater than and my greater than and equal to. Okay, so that's how you're going to take an inequality and put it on a table. So hopefully that helps out.